If you like slot cars and you like to tune them for maximum speed and handling, this video is going to show you how you can build a very cheap tool out of a jewelry scale to measure magnet downforce of individual magnets as well as the entire car. So I want to walk through the process of how I fabricated this and then do a demo on how the unit works. So first of all, this isn't my idea. I got it from Vitamin50. He's got a great YouTube channel and a lot of technical videos on slot car topics. And the unit that he got it from a smoke shop, and the scale, this plate right here, was made out of a metal that would attract a magnet. Now this unit that I purchased from Amazon for about 12 bucks, this is a high quality stainless steel, must have a lot of nickel, but it's not able to attract a magnet. So I wanted to figure out how I could modify the machine so that it could do what I needed it to do. So I'm going to walk through the fabrication process. So here's the unit here. And underneath this steel plate is where the stainless steel scale plate was, and still is. So what I've done is I've taken a very thin sheet of metal, which is scrap that I had from roof flashing. It's very thin. You could cut it with snips, and you could sand it with a hobby sander, make the corners nice and round, which is what I did. Now to fasten this to the stainless steel, I just wiped off the surface with Windex on both the steel and the stainless steel side. And then I got the contact cement. So if you never use contact cement, which this here I think I got from Home Depot, it was just a couple bucks. You could just simply, there's a little brush in here that you just brush a little bit on the plate. It doesn't take much, maybe almost the size of a blob that might fit on your fingernail, and you spread a very thin coat on both surfaces. So I did it on the surface of the stainless steel and then the bottom side of this plate. Waited 15 minutes and then I stuck it on. And this is what you have. It's perfectly flat. Now it's important to not be a thick piece of steel because you need clearance when the lid closes, which there's plenty of. You can see in there, there's still plenty of clearance even though I haven't shut it. And the reason why this is important, because for a magnet downforce tester, well, first of all, you can see how this attracts a magnet now. See that? So it's magnetized. So when the unit's closed and you put a magnet on this plastic, what it's going to do is it's going to pull that plate up. That plate on the scale wants to come up. So what will happen is you'll get a negative reading here, which is a representation of the force of that magnet lifting up that hypersensitive scale plate. So that's how this works. And what I did is milled out these two openings here so you could turn the unit on and you could see the digital reading with it closed. So in essence, we're having the scale, instead of being a measure of force down, we're measuring force up. In this case, the magnet trying to pull that little metal plate that we just installed up. Drilled this little hole here so that you could put the pin of a slot car in there. So when the slot car is on this, you could measure the downforce of those magnets on that plate. Now, which you have to account for the chassis design as well as the height of your wheels, because the further this is away from the plate, the more diluted that measure gets. Just to show you how sensitive this is, I'll show you a little demo of how this is going to work. So when you turn the unit on, I have it set to grains. You could set it to different forms of measurement, but grains is fine. When I take this magnet here, which is a magnet traction magnet, a stock magnet traction, and I just start waving it close to the surface of that plate, look at that. I'm not even touching it. And then when I set it on the plate, you can see I get a rating of 8.20. Now notice it's negative because it's showing the force pulling up on that plate. And the scale's sensitive enough to get a reading for this little magnet. I'm going to put that off to the side. And we could show what a stock red magnet for an AFX car would show. That's a pretty strong magnet for a regular AFX. That's a 9.76. Here's a green magnet. So that one's a little bit lower at 7.61. So that would not be a good pair for this magnet here. This magnet was a little bit higher. So what we're trying to do is pair our magnets such that the reading is pretty close to the same. Now this is interesting. I got these OS2 Blue Dragons, and look at that, that's 11.57. So that's a front magnet. Here's a rear magnet. It's close to 11. Now these aren't necessarily ones that I would pair together, but you can see they're pretty close. And I found that the order that I got from the guy that sells those, the magnets are pretty consistent. So most of them will pair with each other. So that's how that reading works. So what you don't want to do is have this scale moving around, because if you pick it up, you can see that scale so sensitive. It's that little calibration, it doesn't know what's going on. So you want to keep your scale flat on a surface. So this little magnet here, in order to minimize the variables on this, because remember, it's not a precision instrument like you would buy to actually test magnets. Those kind of instruments cost $200 to $300, $400. And I don't need that level of precision. I just need a numeric value to differentiate the variances between the magnets so that I could get like pairings, so we have balanced motors when they're assembled in the car. So all I did here to get that little magnet, I just got a Sharpie oil-based paint pen, which is what I use to line the AFX tracks to create the lane colors. And I just blobbed a little on here, and then I turned it upside down and just pushed it right on like that and stamped it. And this will allow me to put at least the crescent magnets on the surface in the same place all the time, so that I'm minimizing the variables when we do a measurement. Okay, so why don't we do a measure on some cars, and you can see the downforce that a car pulls. Now remember, the downforce won't necessarily equal the sum of the two magnets in the car, because the car is not perfectly flat on that plate. It's away from the surface, so the reading gets diluted a little bit. But since you're putting all your cars on this, you can at least get ideas of how sticky your car is. So I'm going to turn the unit back on, because it'll turn itself off if you don't do anything with it for a few minutes. Now, this is a restored standard AFX. This chassis I had when I was a little kid. It's got a Johnny Lightning body on it. This car is really fast. It's got mean green motor armature and the Blue Dragon magnets. Now you can see the downforce here says only 2.30, and we know the two magnets in there should have a cumulative downforce when laid flat. They were testing 11, so it should be like 22. So that's most likely due to the combination of the spring tension, and I've got some pretty big silicons on here that actually do really well on this car. It tests at almost a 3.0 on the dyno. So I'm real happy with that. Now the next car, this is a restored childhood magnetraction that I have, and we'll see what the difference of this one is. So that one's got some pretty good downforce compared to the other car. This is a 8.71. Now we're going to go up a generation. So this is an Auto World. This has got the little magnet on the side here, magnetraction setup. These are the Ultra Gs. So we're going to put that one on there. Now look at that, that's 20.0. So remember, that's not the weight of the car. The car's not putting any weight down on the scale. It's the magnets pulling the scale up. And then we're going to go to an 80s AMRAC. These cars are real sticky if you've ever driven them. That's a 26, almost 27. And then a 80s, late 80s, early 90s Tyco. Get that in that pin. That's 25. Yeah, these cars will stick upside down on a loop if you have loop tracks. And then here's one of my original G Plus that I got in '77 when I was a kid with Christmas money I got from my grandmother. And the car's really fast on the dyno. It's like a 3.34, and it's not all that sticky, but at least on the meter. But I'm happy with that. And then here's a more modern G Plus, Super G Plus, got in about 2005. And that one's a little more sticky. So you can see how, now what you could do is actually measure all your cars. You can look at their performance, you can look at the dyno, and you can see if you got a car that's just not running right for some reason. It could be you got a magnet that's not balanced with its sibling. And this will allow you to, solve those kind of problems as you tune your cars. So I hope this was helpful. It works sure for me, and one of the things I'd like to show you that I've done is, I've created this spreadsheet with all the cars on it, and I have the dyno reading here, and I plan on adding another column that has the downforce reading. So if I get into a certain class of car, like these non-magnet tractions, and I got some that are performing low on the dyno, and they're tuned with good parts, and they're clean and oiled. Why, for example, is these two down here running at like 2.05, but I've got other cars running above 3, or the mid 2s. So this could be real helpful in tuning the cars that just seem to be lagging behind in performance. So there you go. Got a little tool, 12 bucks. Give it a try. It's real easy to build. If you've got the skills to tune your cars for slot cars, you definitely have the skills to easily fabricate this little thing. All you need is a Dremel tool and some sheet metal from roof applications. It's very, very cheap. This whole fabrication cost me maybe $12.50 if you factor in glue and the metal, which I already had in the house. So that about wraps it up. If you have any questions, drop a comment. I'll answer what I can. And call out to Vitamin50 for helping me learn how to tune my cars better after 40 years. They've been mothballed, and pulled them out, got them all tuned up, and having a lot of fun with them. Also, Slot Car Crazy has some great videos as well as far as tuning the cars and how to use dynos and things like that. So thanks for watching. Signing off.